Okay, these last couple sections, 12.5 and 12.6, we have some formulas we've got to learn and learn how to use them. And the first one we're going to start out with is the volume of a pyramid, where the volume of the pyramid, I'm going to tap my, there we go, no, sorry, volume of a pyramid is 1/3 of the area of the base times the height. So with a pyramid, where I come up to this point right here, okay, all the sides come up to that point, then it's my base times my height, but I'm not talking about a prism anymore, it's a pyramid. So I cut out a little chunk and I get 1/3 of the area. And so you've got to just learn how to learn the formulas and learn how to use them. Volume of a cone is going to really be the same thing. It's 1/3 of your base times your height. But again, with a cone, think about what that base is. The base is a circle. So my volume is going to be 1/3 of the area of the base, which is pi r squared for a circle, times the height. So that's going to be your volume formula. So let's find the volumes of some solids here. This first one, A. The base that I'm looking at is a triangle. So for a triangle, remember my volume, not the volume, but the area of the base that I need to find. The base is a triangle, so area of a triangle, let's do the base first, is 1/2 the base times the height. Since it's a right triangle, one of these is my base and one of these is my height. So I'm going to get 4, 6, and divide by 4 times 6 divided by 2 is going to be 12, and that's meters squared. Okay, so that's the base. That's the area of my base. So now let's do volume. Volume is 1/3 the area of the base, which is 12 meters squared, times the height. Now for this particular figure, it gives me the height of the figure itself, and that's the height I need. So this 9 is pointing to the line that's perpendicular to the base down here and goes all the way up to the vertex. So that is the height of the solid. So I get 1/3 of 12 times 9, which is going to be 36 meters cubed. Okay, so that would be your volume of that solid. So let's go over here and look at the next problem. We've got a cone where my base is a circle, and so first thing we could do is find just that capital B, the area of that base, which is pi r squared. Okay, pi r squared, my r is 2.2, and then that's squared. So my base is 15.2, and that's centimeters squared. Okay, so let's find the volume. Volume equals 1/3 times the area of the base, 15.2, times the height. And again, they give me the height. It's that perpendicular at the base, so 4.5 centimeters. And so my volume is going to be 22.8, and that's centimeters cubed. Okay? Okay, let's take a look at number 1 here, this hexagonal pyramid. So remember that it's the area of the base times the height divided by 3, or 1/3 the area of the base times the height is your volume. But let's take a look at what that base is. That base is a hexagon. Let's see how well I do at hexagon here. That's not too bad. Okay, there you go. There's a hexagon. But remember how we find the area of that base. The area of the base for a hexagon is going to be your apothem times your perimeter and then divided by 2. So we're going to need that central angle. And there's the central angle that gives me the isosceles triangle. And what do we know about it so far? So far, all we know is that I have side measures of 4. Well, let's drop in that apothem. And there's my apothem. And so once I put the apothem in, then each of these is 2 yards. And if you remember, the central angle in a hexagon is 60 degrees. And I can do that up here, I guess. Central angle, if you remember, 360 divided by 6 sides is going to be 60 degrees. So when I divide the central angle, which is 60 degrees, by 2 to get just one angle, I'm going to get 30. So 30, 60, 90 triangles. Now remember, across from the 30, this is my x side, right? That's my x side. And the apothem is across from the 60 degrees, and so the apothem is my x square roots of 3 side. And so my apothem here is 2, that's my x, square roots of 3. That's your apothem. Okay, 2 square roots of 3 is apothem. Now perimeter, remember that each side is 4, and if I have 4 sides, that makes my perimeter 4 times 6, 24. So the area of just that base is 2 square roots of 3 times 24, divided by 2. 2 square roots of 3 times 24, and then divide that by 2, and that gives you the area of that polygon. So we can look at that. Those twos are going to cancel, and I'm going to get 24 square roots of 3. That is the area of the base. All right. So we'll look at now the volume of that figure is the area of the base, which is 24 square roots of 3, times the height, and they do give me the height, that's this piece right here, they give me the height of 11 yards, and then divide by 3, or you can look at 1/3, 24 square roots of 3 times 11, and if I put all that in my calculator, first let's look, I guess, at exact, and I would get 24 divided by 3 is 8 by times 11 is 88 square roots of 3. That's exact, so I get the equal symbol. And if I want approximate, put that in your calculator, and I will get 152.42. And that is yards cubed. Volume is a cubed unit, always cubed unit. We just did a cone, so we might save this cone and then maybe just do some on the worksheet. So let's go to the next slide. I have the volume of a right cone is 1350 cubic meters. We've got a cone, so remember the base is a circle, where my radius is 18 meters, and we want to find the height. That's what we're looking for, height. Volume equals area of the base, which they gave me, let's see, hold on. Let's do the area of the base times the height, and we're going to divide by 3. 1/3 the area of the base times the height. So fill in everything that we do know. The volume is 1350, and make sure you put that pi in there. It's 1350 pi equals my base, which is this, in this case is a circle, pi r squared. So I'm going to get pi. My radius, which is 18, so 18 squared. And then we're looking for the height. The height, remember, it's divided by 3. Area of the base times the height divided by 3. So I can do two things here. I can either multiply both sides by 3 to get rid of the fraction, or I can do the 18 squared and divide by 3. And if I do the 18 squared and then divide that by 3, let's rewrite. I've got 1350 pi equals, and then I'm going to have, what did I just get? It's 108 pi times the height. So remember, we're solving for height. So at this point, I'm multiplying height by 108 pi, so let's just get rid of it. Let's divide by it. 108 pi on both sides. 108 pi. So those are going to cancel, and I'm going to get just my height, h. And the h's, or the pi's over here will cancel. And 1350 divided by 108, my height is going to be 12.5. And this is in meters. My height is in meters. Okay? Let's look at the example number 3 here. We do need to take a look at example number 3. Find the volume of the right cone. So remember volume, 1/3 or the area of the base, pi r squared, times the height divided by 3. All right, so one thing we have to look at here, volume of this cone, is that I have the height, 16 feet. I do not, however, have the radius. So that's the letter right here we're looking for, the radius. I have an angle measure. And so we have to be able to visualize here, and I will draw it, that here's the height of my cone, right there. And then if I look at that radius, that's a right angle, isn't it? And show me that in red, that's a right angle. And so I get one of these right triangles that I can solve. So I have 65 degrees. The side that I have a measure for from 65 degrees is the opposite leg, and I'm looking for the radius, which is the adjacent leg to that angle measure. So if you remember, opposite over adjacent is tangent, so I'm going to have to use the tangent of 65 equals the opposite over the adjacent, and that's how I'm going to get the radius for this problem. So tangent of 65 equals 16 over r, and if you do the cross multiplication and you solve, you'd see that when your variable's on the bottom, these two are going to switch places. So I will get r equals 16 divided by the tangent of 65. Okay, so plug that into your calculators and we get a decimal, which is 7.46. Now I can find the volume. That's my radius, so here's my volume. My volume is pi times my radius, 7.46. That didn't come out right. There we go, 46, times pi r squared, and then times the height, which is 16. And to that, we're going to divide by 3. All right, so we've got decimals here, and we're just going to go with decimals. So this one is 932.45 feet cubed when you put all that in your calculator. Okay, last one here. We're going to look at the volume of this composite solid. So if you look at this, we have on the bottom, I have a cube on the bottom, and on the top, we have a square pyramid. And so I have to find the volume of each, and then I'm going to add them together. So remember, with the composite figures, you're going to break them up into pieces that you can manage, that you can find the volume of. So let's find, to get the volume of the solid, we'll go ahead and write it down. To get the volume of the solid, we're going to take the volume of the cube, and we're going to add the volume of the pyramid. So let's look at the volume of the cube, or the pyramid first, the one on the top, and that's going to be, actually, let's just fill in right underneath this, the volume of the cube. Remember in the first slide, that was s cubed, side times side times side, plus 1/3 the area of the base times the height. So my sides are 6 times 6 times 6 right here to get the cube. So I've got 6 cubed plus 1/3 6 squared times 6. Now, one thing it's really important to remember here, and let me write this, if you write it this way, 6 cubed plus, and then I have 6 squared times 6, and if you do the 1/3 as divided by 3, notice that you're only dividing the second part by 3. We don't want to divide everything by 3. You're only dividing the second part. So when you start plugging these things in, pay attention to that. And so 6 cubed is 216, plus, when I do this, 6 cubed, again, 6 squared, and then times another 6, and divide it by 3, I'm going to get 72. And so that equals 288. Again, it's a volume, so we've got meters cubed. And there's a composite figure. So remember, break them down into manageable parts, and then add them together. And that is 12.5.